Thank you everyone for joining us today. We've got a lot we're going to go through. We're going to kind of start basic with some of the basic, philosophies of APFS and where things have gone from HFS to APFS, and then we're going to get into some of the artifacts that we can look at that. We're going to talk about the T2 chip and how that's a bit of a pain for investigators to deal with, and some strategies of dealing with that. So with that, quick introduction on myself. I joined Magnet coming up on 2 years ago now. Previous to that, I was at Capital One doing technical investigations, insider threat, also working on their education and awareness team. Before that, I spent time in law enforcement, both at Rock Hill PD, CID, and Professional Standards Unit, as well as Special Deputy U.S. Marshal on the Secret Service Task Force. Feel free to add me on LinkedIn, Twitter. Feel free to send me messages via email, via LinkedIn, Twitter, however you may want. But with that, we're going to go ahead and kind of jump right into it. So today, like I said, we're going to talk about APFS. We're going to understand the basics, and then we're going to start working through imaging the Macs, and then also some of the Mac artifacts. And I'm going to throw out a couple tidbits there, as well as talk about some of our roadmap options for Mac as well. So with that, let's go ahead and start talking about the basics, because we have a lot to go through today. So the APFS Apple file system, it's important to realize that when you are dealing with essentially anything in the Mac world now, it's going to be APFS based. So you're dealing with the watch, you're dealing with the iPad, you're dealing with the iPhone. It's all going to be premised on APFS file system. So that's a good thing for investigators, because that means we can learn the one file system and then we understand it. It's not going to be segmented to where one is APFS, one's HFSX. We're going to have just standard APFS now. So APFS at a glance, what are we talking about here? Well, it replaced HFS Plus, which had been around since 1998. So HFS, a little long in the tooth, it was time for an upgrade. So Apple went ahead and said, you know what, let's go ahead and make our own file system here. And APFS was originally previewed in 2016 with 10.12. 10.12 didn't allow users to access the APFS functionality, though, unless you were inside of Terminal. With 2017, High Sierra, which was 10.13, this included that full APFS support and included that upgrade to APFS from HFS Plus when users did that upgrade. And then iOS 10.3 had that APFS upgrade. So, 10.3, you're talking March of 2017. You would think going from HFSX to APFS, that might be like a big release for iOS, but they just included that as one of their dot releases. So just keep that in mind, one file system for all Apple products at this point. So something just to be aware of when you're working with these different devices. We're going to talk about iOS versus Mac in a little bit as well. So why the upgrade? So HFS, like I said, 1998 with macOS 8.1. It didn't natively support disk encryption. Back in the 90s, encryption really wasn't as big of a deal as it is, in the 2000s and especially now. File Vault 2 was added later. The timestamps for HFS were only to the second. And then, the support for up to 4 billion files, which, 1998, 2000, everyone thought, we'd never hit that 4 billion, file mark. But that being said, guess what? We came close. Computers started hitting those numbers. HFS needed that upgrade. So with APFS, it's built to be optimized for SSDs, for flash storage. It has that native encryption built in. We have snapshot support, which we'll talk about later on as well. We have 1 nanosecond timestamps now, so much more granular than what the to the second timestamps of HFS were. And then support up to 9 quintillion files. So, tack on 18 zeros onto a 9, and that's quite an extensive upgrade from 4 billion files. So, that being said, I'll be curious to see how long before we start hitting near that number, but I assume it's going to be a little bit. So let's talk about the timestamps. So at the top we have HFS Plus, which are to the second, so 518, 42 seconds. If we look at that same timestamp with APFS, go ahead and add on 9 zeros from that second date, and you'll see that 8 way out there. So just be aware of that. And I've got the kind of conversion on the right-hand side if you want to break that down, but know whether or not your tools are supporting nanosecond or to the second. Are we going to need nanoseconds? Is it going to be really, really, do we need that level of, granular access? Perhaps we do, but to the second seems to be granular enough for most people, but just be aware of how your systems are tracking that information. It's definitely important to have that. Next, we have the encryption. So like I said, HFS had no native encryption. We had to rely on core storage, which was great because core storage gave us a logical volume management. And a part of that, we got fusion drives. Fusion drives became pretty popular there for a little bit because essentially it fused an SSD and a platter drive to this one logical volume. Why did we do that? Well, at that time, SSDs were very expensive. So with a smaller SSD paired to a larger standard hard drive, we could get a good bit of performance increase. So with a lot of the devices like the iMacs or Mac Minis, or a lot of people creating their own fusion drives, we had to deal with being able to access that data, and we had to be able to do it, via HFS and core storage. So definitely keep that in mind. And I still have people reaching out saying, hey, I grabbed, I took an iMac apart, pulled the screen, grabbed the platter drive, imaged it, and it's saying no OS detected. What's going on? Well, guess what? There's still going to be, fusion drives out there, and they're probably still running an older version of macOS, and you're going to have to create an image of both of those different drives. And we'll talk about imaging here in a little bit, but something definitely to be aware of. Now, APFS has that native encryption. So we can either run no encryption, or you can have one key per volume. And that volume encryption key, or the VEK, is the default key to decrypt the content of each volume. But you need the key encryption key to unwrap the volume encryption key. And the key encryption key, you can use the user password, the personal recovery key, institutional recovery, or the iCloud recovery key. So once again, keep that in mind. APFS encryption uses AES XTS or AES CBC encryption depending on that hardware. APFS encrypts data blocks using that XTS AES 128 cipher, and in order to decrypt that, we need several pieces of that information. We need that encrypted data. We need the 128-bit volume encryption key, and then we need that secondary encryption key along with that original block number of that file so we can get that data out. Now, as we are moving forward, we also have other things that we need to deal with. So system integrity protection, or SIP. That's been around now for a little bit. So released in 10.11, essentially SIP prevented users from creating images of physical drives or APFS containers while that Mac was running live. So, the standard practice of, you got on scene, you had a live running Mac, you were able to use one of your forensic imagers to go ahead and image live. Well, SIP prevented that. Restricted that root user access on several different folders inside of that system, such as the system bin, the bin, and then apps pre-installed, with macOS 10. So something just to be aware of. Now, as you can see on the right-hand side of the screen here, SIP can be disabled. Now, it's always worth noting, I don't really recommend doing that, especially in the law enforcement section, because obviously you're changing the makeup of that machine. But if you are doing some testing and you want to learn just a little bit more about macOS, it's good to be able to work through some of this and understand what you're doing while you're making changes to these machines. So something to be aware of. SIP got a huge upgrade with Catalina, which we'll talk about later on today as well. But we need to be aware that there's lots of different levels of protection on these Macs, and we're going to have to navigate them in order to get the evidence that we need. So moving on, we have the T2 encryption. So this has been around since late 2017 with the Macs. It's not going anywhere. The new Macs are going to have the T2 chip as well. And the Mac unique ID and the device group ID are 256-bit keys fused to the secure enclave during that manufacturing. So that being said, the old school way of, well, I'll just take the computer apart, pull the drive, or I'll do some sort of chip off and I'll be able to get the data. That's not going to work with T2 chip encrypted drives, because you're going to have to pull that encrypted data through that secure enclave to get the unencrypted data so that you can then process it. And there are some tools out there that will allow for doing this, and we'll talk about that as we get to the imaging. But it's important to note that you have to be able to deal with the T2 encryption. That's going to be a huge pain point. Now, with the T2 chip encryption, we got some more difficulties, especially when we're talking, for the law enforcement sector, who might not have, institutional recovery keys or iCloud recovery keys that they readily have access to. So that being said, we have the startup security utility, which you get access to by going into recovery mode. Now, the startup security utility kind of is the replacement for the firmware password utility, which you can see here on the right-hand side of the screen. You can still turn on that firmware password. But part of this is, it requires booting into recovery mode. And guess what? In order to start making changes to that startup security utility, you're going to absolutely have to have that admin password. So once again, if you don't have these things, you're not going to be able to access this information, and it's going to leave you a little bit stuck in order of, how you're going to grab that initial data set. So that being said, here you can see under Secure Boot, we have full security default configuration, which means you have to have a current OS or signed operating system currently trusted by Apple so that you can run, that on that Mac. You might need to change that depending on what imager you're using and what level of, current OS they have kind of built into that imager. Also, if you look down at external boot, disallow booting from external media. So if you're using bootable imagers, whether it be Samari's Imager Recon Pro or Blackbag's Macquisition, you're going to have to come in and change this in order to be able to boot to those drives to then make that image. Now, fortunately, though, we do have target disk mode that is still an option. Target disk mode, essentially turning that Mac into, the world's most expensive hard drive, where you can then run Macquisition or, Imager Recon Pro on your Mac and connect via USB-C or Thunderbolt connection to be able to then acquire that data. What's great about this option is you don't have to worry about the external boot options, because essentially you're just plugging this into your Mac, and your Mac is the one actually running that software and kind of driving that software. So target disk mode is still a great option for making images, especially if you are having to deal with a T2 encrypted Mac. You're going to have to kind of work through the secure boot and external boot options as a part of that. And with the target disk mode, you're going to be able to bypass that. Now, with the encryption, brute force attacks prevented just like on iOS. Why? Well, iOS is APFS as well. So no more than 30 password attempts at the login window or target disk mode. You get 10 more attempts after going into recovery mode, and then you get 60 additional attempts with the recovery key, iCloud recovery, and institutional key. And you kind of look at the delays between the password attempts. So once again, when you're getting above 30, you're going to be waiting a while for each attempt. So with that being said, you're going to get roughly 220 attempts out of this, but that's going to take you a long time to kind of get through if you were trying to guess the passcode. But just be aware, you're going to start running into those password attempts and the delayed enforced, on that when you are guessing and getting the passwords wrong. So Touch ID on Mac, password required to enable that Touch ID. So, once again, what was the SOP for a lot of people, 5 years ago when you got on scene? It was automatically shut everything down. We'll figure it out in the lab, but don't start making changes or doing anything while you're on scene. And really, that could be pretty bad advice now for a lot of different devices, especially Apple devices. So if you get on scene and they've been using the Mac, guess what? The Touch ID might still be a viable option, especially if you can compel people for biometrics. Some states do, some states don't, but definitely up to your jurisdiction. But the password is going to be required if the device has just been turned on or restarted, if the device hasn't been unlocked for more than 48 hours, the device has received a remote lock command, and then 5 unsuccessful attempts to match that fingerprint. So be aware of that. You're not going to be able to keep compelling them. Think about what finger you might want to compel them to use if you get that option. Otherwise, you're just going to lock it out to where you have to have the password all over again. Now, we also have Face ID and Touch ID for iOS, and since iOS is APFS, I'll just briefly mention that. So once again, if you get a phone, really the worst thing you can do is shut it down, because you're going to go from an AFU mode to a BFU mode if they've unlocked it and been using that phone. So keep that phone active, obviously secure it from the network, but if you do have to reboot the phone and start over, that password is going to be required. If the phone hasn't been unlocked for more than 48 hours, guess what? You're going to have the passcode again. If the device receives that unlock command, or once again, 5 unsuccessful attempts to match the face or the fingerprint ID. And then if they initiate the power off or emergency SOS, it's automatically going to require the passcode once again. Another piece that's not documented anywhere that I have found to date is the SIM removal. So if you pop the SIM, if they have had their fingerprint or Face ID working, guess what? It defaults back to where you're going to have to put the passcode in all over again. So just be aware of that. Now, Collection options when we are dealing with Mac. There are several out there. So Blackbag has Macquisition. Macquisition supports T2 chip decryption to where you can pull, the volume over of that APFS container and be good to go. Samari has Recon Imager Pro. Once again, you can collect data in a logical format and pull that over from different Macs. So definitely keep that in mind. There's also options out there like Brymore Labs has a bunch of essentially scripts that you can pull a bunch of logs over, just logically. And then last, you can see Magnet Forensics. So in a new and upcoming release of Axiom Cyber, we will have remote acquisition capabilities of Macs. And I can say that's for both T2 chip and non-T2 chip based Macs. You'll be able to deploy an agent, collect logical data from that Mac, and process it inside of Axiom. So definitely stay tuned for that. That'll be coming in the very near future. So when we are talking about APFS imaging, we're going to have to make some decisions here. And when you're looking at this, you can see on the left-hand side, pre-10.15, when we are looking, we can see at the very top, we have disk 0, which when we're looking at this, we have a container disk that will be the full size of that drive. But then underneath that, we have dev disk 1 that says synthesized. So that's going to be your actual APFS containers. Now, as a part of that, when you're looking at this, you can see the different APFS volumes that are associated with that disk 1 of that synthesized APFS container. We have Macintosh HD, we have Preboot, we have Recovery, and we have VM. That's typically what you're going to see when you are looking at APFS Macs, are those 4 volumes. And then you're going to also be able to see their sizes and their identifier. So dev, disk 1, slice 2. So you're going to have those options there. If you are looking at potentially a newer machine, so 1015 with Catalina, which has been out now for a little bit, you're going to see something more along the lines of what's on the right here. It's still going to be dev disk 1. It'll say synthesized. But when you're starting to look at the different containers, you're going to see Macintosh HD, and you're also going to see Macintosh HD-data. So that's a new volume that's now associated on Macs when you upgrade to Catalina or 10.15, which we're going to talk about here in a little bit. Something else important to note as associated with when you're looking at different volumes and how the Macs are looking at this is we talked about fusion drives earlier. If you look at a Mac, whether you are running whichever imager you're using, I'm just going to use Macquisition for the time being, you're going to probably see a disk 0, a disk 1, and a disk 2. And the disk 2 will typically say something along the lines of merge data from disk 1 and disk 0 with the Macintosh HD. And that would be what you would want to image, is that merged data. That's going to be for that fusion drive, though. Once again, keep that in mind. But for the newer Macs where they just have one drive and just a standard build, you're probably going to see something along the Macintosh HD and the Macintosh HD-data. If they have, for whatever reason, changed the name of their internal drive, that will be reflected here as well. So it might say something a little bit different. So for instance, my personal Mac is actually just Mac HD. So be aware of that. Now, let's keep going. Let's see what else we can do here. So macOS 10.15, Catalina. So farewell to iTunes. iTunes is gone now. The syncing of devices is all handled by Finder. And instead of having iTunes that kind of supports everything, we have a separate music, podcast, and TV app now that's associated with the Macs. We also have Sidecar built in, so using iPads as that secondary display. And we have Screen Time, which has been around now for a little bit with iOS. So we now have that on the Mac, which gives us a great database for tracking usage time, notifications, and pickups. And then Mac decided no more 32-bit apps. So if you notice, potentially if you're running Macs in your own environment, if you had 32-bit apps, guess what? They probably stopped working after the upgrade to 10.15. Now, along with that Catalina upgrade, we have that new read-only system volume. And this is going to be essentially, think of Microsoft's Reserve Storage in Windows 10, 1903. This is going to be that protected folder, system file, and pre-installed apps for your Mac. It's going to create a volume group that links that system data in the data columns, essentially using firm links, which allow for the symbolic links without the duplication of files. So essentially, you're not going to have duplicate files everywhere on your system, and it's going to protect your system a lot stronger than just the standard zip that just protected a few folders. Be aware, if you are doing an exam and you see a folder that says relocated items inside the user's home directory, that's going to be the different files that were located in paths that now are only read-only. So Apple essentially just moved everything that might have been all over the system that a user had put there to a relocated items folder, since they're not going to have read-write access to parts of their system now. And examiners are probably going to be wanting to look for that hyphen data folder. So if we go back two, you're going to see the hyphen data here. That's going to be that user data that you're going to be looking for here. So just be aware of that. Now, what else did we get with Catalina upgrade? So we got improvements to Gatekeeper, checks for all the apps for security issues, requires apps to get permission before accessing user docs, desktops. So you're going to get a lot of more prompts inside of Catalina than you have in the past, because once again, they want to make sure users are aware that these different apps have access to different parts of their system. We have activation logs, so users can reactivate or erase data from missing devices. And then we have Find My, which is the locating missing Macs or iOS devices not connected to the internet using Bluetooth of nearby Apple devices, which are pretty interesting and something that we're definitely doing a lot of research in. So let's talk about some of the artifacts that we're looking at now. And we're going to start pretty basic and kind of build from there, but the menu bar. So the reason I put this in there, because a lot of times on the different listservs, you'll see like, hey, can anybody tell me what this specific icon is in this menu bar? I've never seen it before and I want to research it. Well, if you look inside the system, UI server plist, you can actually see the list of all the different pieces of that menu bar for a user account. So you can go ahead and look at that so you can start doing your research if you see something that you're kind of curious what's running there. The KnowledgeC database. So we've known about this on iOS for quite some time. Obviously, we have this on macOS as well. And the SQLite database is going to track all sorts of things like application activities. So you're going to get a good understanding of what they're doing inside of different apps. You're going to see the focus of those apps. So you'll know what they have in focus on their screen at any given time. You'll be able to see when the device was plugged in and maybe the screen backlight states. Why is this important? Well, maybe you need to put somebody at the scene or at their computer at a specific time. Maybe for HR investigations, were they actually on their computer when they say they were? This is a good way to be able to see that, because if their screen's off, probably a good chance they might not have been doing much work. And then we have Safari history. Now, the Safari history is really interesting because a lot of times people might try and hide what they're doing, or they might try to erase their typical Safari history. But guess what? KnowledgeC is a separate SQLite database, and it still stores that Safari history. So you're going to be able to see that information. The only downside to KnowledgeC is you're looking at roughly about 28 to 30 days worth of data. It's not going to be a full historical context of everything that's gone on that Mac. It's going to be about a 28-day snapshot for you. On iOS, you're going to have additional pieces of the KnowledgeC, such as installation and uninstallation of apps, which is great. You can show how maybe they had just installed an app, or they just uninstalled an app because they knew that they were being tracked. Great information. And then down at the bottom, you can see the different locations of that KnowledgeC database. So well worth an investigator's time to kind of look through the KnowledgeC database and see the different points of interest that might be worth your investigative time to kind of look at there. So Bash history. So Bash is the Unix-based shell program for Mac and Linux OS. Bash is the shell program that we use for Apple Terminal. You can also use other tools like iterm2, which is totally supported and writes to that .bash_sessions folder. So keep that in mind. Catalina got an upgrade to a .zsh_history. I will tell you, we are working on supporting that inside of Axiom with a dedicated artifact. So stay tuned for that. That should be coming out in the very near future. But for your own research, if you want to kind of see what's going on inside your bash, you can just go open terminal and just type in open, .bash_history, and you're going to get a running list of everything that you have done inside of terminal. Now, when you start running bash, you're going to have a couple of dates you want to look at. And on the right-hand side here, you can see the preview of what I ran as distkutil list and list all the file systems, and then showing all files inside this Mac, so showing all the hidden files. And as you can see underneath the details panel, you get a session ID, the user, and the start and end time. That start time is based off that term session ID with the history new created, and then that end time is going to be the term session ID.history, which is essentially when we close that window out. So definitely keep that in mind. Also, once again, if you're doing testing on your own and you're using a Mac, make sure and do that defaults right com.apple finder, show all files, and drop that command in so you can get a better picture of what you're seeing on your Mac, and you have the ability to see all those hidden assets. Now, FSEvents or file system events, this is a huge resource and a goldmine of data for Mac investigations. Think the USN Journal, but for Mac. You can find this on the root of the system partition. It's going to be, the .fseventsd. You're going to get a lot of logs, and they're all going to be gzip archived files. And you're going to get file IDs present. This is awesome for sequencing events on that computer. You're going to want to be very kind of targeted when you are looking at FSEvents, though. You're going to want to look for essentially maybe key phrases like mounts, volumes, or Safari or Chrome, knowing potentially what browser they're using, or things like renamed or .trash to help kind of fine-tune your search. So here you can see we have some FSEvents loaded, and we did a quick search on the file paths on the top right here, and we can see the volumes. And under the flags, you see mount and unmount points. This can be fantastic for USB investigations if you need to know what volumes are being mounted and unmounted on your investigative laptop. So you can see things like CC Cleaner was mounted and unmounted, and we have things like BitTorrent being mounted on this system. It's important to note too, if you get a file being moved around on that same volume, it's going to get a renamed flag under the flags column. So you'll see a .rename. That's going to be because it might have moved around on that system. But keep in mind, you can look up for file path, you can look up .trash to see potentially things being moved to the trash. This is great for, like I said, sequencing events. So potentially you're going to be able to say, they created this document, then they deleted, X, Y, and Z, and kind of build a timeline just based off the FSEvents of that Mac. Now, it's important to note when we're looking at FSEvents that when you are processing a Mac case, underneath the artifact options, FSEvents are going to be turned off automatically for iOS investigations. And we did that because you're going to see, you could see 3-4 million FSEvents on a typical used iPhone, that you're using day in and day out. A lot of times in iOS investigations, they're not going to be super important, but it's worth noting you can go in and check that if you want to have all that data. It just might take a little bit more time to process all that information out. So keep that in mind. If you check everything inside of Axiom process when you are doing an APFS investigation, FSEvents could take a little bit of time to chew through, just essentially because there could be hundreds of thousands, if not millions, of events that we're parsing out. USB connections. So there's no USB store like Windows, so you got to do a little bit more digging for Mac USB investigations. And we're going to have artifacts to help you along the way here, but we're going to be able to show you connection start times, possible serial numbers, vendor IDs, product IDs, so you can start kind of understanding at least what you need to look for if you think there might have been USBs connected to the system. And I put a little asterisk next to serial number. I always like to point this out. Don't think just because you find a serial number listed that serial number is going to be exactly to one specific thumb drive. A lot of times, especially the cheaper thumb drives, are going to have the exact same serial number. So definitely keep that in mind as well. There's a lot of open source databases that you can use online. This is one of the ones I use. I like it a lot. Essentially, you can put in the vendor ID, the product ID, serial number, and potentially get a good hit back. There are several online resources like this. Some of them even include pictures. So you might be able to get a picture of potentially what that thumb drive looks like, so you know what you're looking for when you go back to their desk or back to their home and you need to keep doing that investigation. And then just to point out here, I've got the vendor ID of 0x5AC here. When you are doing Mac USB investigations, you're going to see this number a lot. This is a vendor ID. 0x5AC, that's actually going to be Apple's own vendor ID. And you're going to see that because essentially everything that's connected to that logic board is going to be considered potentially an external connected device. So it could be a trackpad, it could be the keyboard, the mouse. So all of those are going to be hits in there. So you're going to see this vendor ID quite a lot. So a couple other places we can look at evidence for USB connections. Obviously, we can look at the com.apple Finder plist. That's going to give you a listing of the different volumes that have been connected. So here on the right, we can see we've got a Seagate backup drive. We've got a camera. It looks like another USB-C connected drive. We also have things like Google Chrome, Images 2019, Scenario backup drives, and APFS images, because essentially all of those are different volumes. Now, people are like, well, why is Google Chrome listed in there when you have a bunch of other externals? Well, think about it. When you download a DMG from the internet, that's going to mount to your system as a volume. So that's why that would be listed there. Just as if you connected one of these external drives and opened it, that's mounting a volume. FSEvents, like we talked about, look for the mount and unmount points, or look for volumes. Good keywords to start getting an understanding of what was connected to that system. One of the logs that's still around that got saved out of the massive purge when they did away from a lot of the standard logs is the daily.out log. The daily.out has a lot of great information, and here you can see a picture where we have the disk device with the information as far as the space available and the mount point. So you can see we got it listed as secret docs. So whatever that drive was when it got mounted, it was listed as secret docs on there. So once again, keep that in mind. And then you have the unified log. You can use keywords like manufacturer or USB MSC, things like that, to start getting a quick call of what's going on your Mac that you're investigating. Now, it's important to note the unified log has millions of hits. It is a massive, massive log. Right now, we are building artifacts out that we are pulling from the unified log, but we are not parsing the entire log inside of Axiom for you to then start scrolling through and looking for. If that's something that's of interest, please reach out to us. We'd love to talk to you about that. But in the interest of keeping Axiom to where it's still snappy and doesn't get bogged down, because you have an artifact that has 10 million hits in it, we're looking at alternative solutions on how we can provide you the entire unified log for your investigation. But keep in mind, a lot of our artifacts that we're building out for our Mac support are being pulled directly from that unified log. Now, quarantine files, I love talking about quarantine files. So quarantine files gives us a good idea of what's being downloaded and what people are doing inside their Mac. So this essentially will allow us to see kind of a running list of the downloads that they've created. And this can be applications from Safari, from Chrome, Opera, Messages, Mail. All of those will start create quarantine files that we can look at. So we're talking about the Quarantine Events v2 database. Now, if you've ever downloaded something from the internet and you get this prompt where you see on the right hand side of the screen here, this is going to be that Quarantine Events database and Gatekeeper kind of working for you to protect your Mac. And Gatekeeper's been around for a while now, 10.7.5, so that's Lion. And this is going to essentially prompt you to say, hey, are you sure you want to allow this outside of the Quarantine Events database when you open it. But some of the things that you're going to be able to get out of this database, date and time, where that file is being downloaded from. You're also going to get Quarantine Events identifier, so you can identify and kind of trace that file around that system. The Quarantine Events database also helps detect known instances of malware. So that prompt on the right-hand side will actually say, this is known malware, to really protect that end user. Also, this little image can even tell you little things like if you see something along the lines of that exclamation mark. That's going to pop up when the apps haven't been notarized by Apple. So you'll get this little icon warning about that. If we keep looking, so the Quarantine Events database, that is a SQLite database, uses Mac Absolute, Cocoa Time. And essentially, here's a running list of what's going on. We have the quarantine information as far as essentially when it hit that database. We have the application that was using for it. And when we keep going over, we can see the quarantine file identifier. Now, this is very, very important because this allows us to track where that file is and what that file is, because there's not going to be a super easy way to really be able to figure out what that file was that they downloaded. One way you potentially can do that is look under the download URL and just pull that box out, and at the end you will probably see what that download was. But that's not foolproof, because as you can see here, we have iChat files and we don't have download URL, so we don't know what those files are. So we're going to have to look up and understand what this file identifier actually is for us to get a better understanding of what's going on here. So if we keep looking here, I ran a quick terminal command, XATTR, and this essentially, I drug in a picture, and this is going to give me some of the extended attributes. So the extended attributes of each one of these files on this file system will have the com.apple quarantine or the quarantine event identifier as a part of that. So if you see in this screenshot here, we have the com.apple quarantine, and as a part of that, you will have the quarantine event identifier that we just saw inside of that database that we can now cross-reference to see that this image, this JPEG, actually has this quarantine event identifier as a part of that. So this is a great way of being able to cross-reference these files. Find what you're looking for, then you can start doing filters and searching on these quarantine event identifiers to get an understanding of, okay, they downloaded it from this location. It's now, here's the event ID for this, and now we know exactly what this file is. This is really important to be able to explain and tell your story to your stakeholders, whether it be to a jury, whether it be to HR. You want to be able to explain how that person came about getting that file, and this helps you do that. You can also see up here, com.apple metadata KMD item where froms. If you don't remember anything else from today's class, remember KMD item where froms, and remember how you can find this information. This is, once again, part of the extended attributes. And here you can see it from a binary P list. We can see we have that information that it came from my iPhone X Max. So now you know exactly how this picture got on this system by looking at this. And this is all going to be part of the extended attributes that you can pull from this file. Now, if you are in an environment that is a mixed environment where you have Macs and Windows, what do you think is going to happen when you transfer this picture from a Mac that's running APFS or even HFS to a Windows that's running either FAT or NTFS? A lot of this data is going to get stripped out because NTFS does not understand what's going on with the extended attributes. So if you're looking at files and you're in a mixed environment and you're trying to look at the extended attributes or spotlight metadata, there might not be a lot there because it might have been moved from a FAT formatted thumb drive and they copied it over to their computer, or they might have gotten it sent to them from an email from a NTFS user, and a lot of that data is going to get stripped out. So just be aware, not all your files will have this, especially in those mixed environments. So looking at spotlight metadata. So on the left-hand side here, you can see I ran a very quick MDLS command. This gave me the spotlight metadata. This is of a picture. And when we're looking through some of this, you can see acquisition make and model. It was an Apple iPhone XS Max. We can see the altitude. We get the aperture of the camera. We can get the creation date of this picture. So we have that information. So we have the creation date. Now, why is that important? Well, once again, if we're talking about NTFS, when you copy something to an NTFS drive, what's going to happen? You're going to get the created date of whenever they did that. But in the Mac world, we have the creation date, but if we keep going down, we also have date added, the KMD item date added. And that's going to be if it moved from one system to another that are APFS or in the same Mac environment, you're going to just have when that was added to this system. So you're going to be able to see the original creation date, which for this was 5/1, and then you're going to see it was added to this system on the 7th. You're going to get the display name, so now you can cross-reference it with the name. And then as you keep going down, you're going to know which camera took this picture, the latitude, the longitude, so you have GPS that's going to be baked into this as well. Now on the right-hand side, this is kind of, I ran out of room, so you're also going to see things such as the received recipient. You're going to get the recipient handle. So now I've got an email. We also have the name, and we also have the handles for the who shared it. So once again, great information to show how files moved onto the system. Whether you're working CSAM cases or maybe data exfil, you're going to be able to coordinate and show how data is being moved around these systems. We also, as you can see here, shared received transport, com.apple.airdrop. So it used the AirDrop service to be able to move this file from the iPhone to the computer. So great information for us to be able to start connecting these dots back to. Now, let's kind of keep moving along. So I just mentioned AirDrop. Now, AirDrop has been around for quite some time. We're talking 10.7 for Mac, and then iOS 7, so 2013. This allows that transfer of photos, videos, locations, DMGs, executables. You can really transfer anything you want over AirDrop. There is no data size limits. So you can essentially just push a huge file from Mac to Mac or iPhone to Mac or iPhone to iPhone, all through using AirDrop. Now they have to have Wi-Fi and Bluetooth enabled in order to use the AirDrop service. And this essentially creates an ad hoc network between those two devices so that they can move these files back and forth. Now, this is a little scary when it comes to the corporate environment, because if you're tracking all your network activity and what people are downloading and what they're uploading, whether it be to OneDrive or SharePoint or whatever it may be, guess what? AirDrop is not going to trigger any of those events. So if you maybe have a rule set up in your network that any download or upload over 2 gigs make some sort of CSOC alert, guess what? AirDrop is not going to do that. You're not going to know. Now, is there a way of being able to track some of this AirDrop? Yes, there is. Also, there are ways of disabling AirDrop as well, and some environments do that. Just keep in mind, a lot of both developers and designers use this all the time, moving files back and forth, but you can disable some of this. Now, you're going to have to kind of go in and disable it, and you're probably going to be having MDMs on your corporately owned Macs, but especially for personally owned Macs and for law enforcement who are dealing with people with iPhone, iPad, Mac computers, AirDrop's probably going to be turned on, and people typically use it a lot. And on the right-hand side here, you can see what that actually looks like with the allowing the discoverability and being able to see what's being close to you with that AirDrop service. Now, let's keep looking at AirDrop. So, like I mentioned earlier, Apple went ahead and kind of killed off and changed, redesigned their logs back in OS Sierra 10.12. And a lot of the Unix logs got wiped away. So things like disk utility, syslog, and slog all got kind of replaced with the new unified log, with everything going through it. Now, there are still a few of the old logs out there, like the daily out log, which we talked about earlier. We also have cups, which we'll talk about here in a little bit as well. But all in all, you're probably going to be looking at a lot of unified log entries when you're trying to do some of these investigations, including AirDrop. So AirDrop, as you can see here, this is actually just me running console on my Mac, and you can see the discovery mode changed to everyone. You can see sharing D. That's important because you're going to see sharing D inside the quarantine events database, and that's going to be listed as a service. So you're going to know, hey, it's probably going to clue you in that this is AirDrop. But you can see things here like the file name and what's going on. You can see the receiver information, the receiver name, the receiver ID. You can also, on the iOS device, look at the sharing DP list to start cross-coordinating this information to connect the dots for your AirDrop investigations. On iOS, if you needed logs that have some of this information in it, you could create a sysdiagnose gzip log by pressing both volume buttons and the power button and waiting for the vibration of the phone. Don't do like I did and keep thinking you did it wrong and your phone vibrates 6 times, and then you go to settings, privacy, analytics, and analytics data, and you've got 6 or 7 sysdiagnose logs that have been created. Now, the kind of funny part about this is Apple actually tells you, since this is a fairly large file, mine have usually been about 30 to 42 meg, to AirDrop the file off the device. So keep that in mind. You're gonna have to pull that gzip off the device, but there's gonna be good AirDrop artifacts that you can potentially pull from that. And then as looking at this, this is inside that sysdiagnose. We can see things like the AirDrop transfers being completed from that log file. Now, kind of wrapping up the quarantine files and talking about AirDrop here, you can see we have the quarantine event identifier. We have the timestamps. We have the agent bundle here that this was pulled from Safari, and we can see, yep, we've got the URL. But if we look here, we have sharing D with the quarantine agent, and that's going to be, go ahead and clue you in that AirDrop's being used. And we can start seeing the sender's information and potentially the device that's being pulled from that quarantine events database. So just be aware of that. Now, Axiom with AirDrop, we support Mac to Mac, Mac to iOS, and iOS to iOS. So you're going to see things like the background activity, you're going to see discoverability, you're going to see potentially the other users that you have been able to see in your AirDrop. We just added that as a separate artifact. And then you're also going to have incoming transfers and outgoing transfers. And it's going to be things like the artifact information here, like, was this a file, recipient information, verifiable identifier. So were they a contact or not? You're going to get the transaction ID, and then we give you the transaction log, which is essentially us just copying and pasting out from the unified log so you can validate what we're pulling here. But as a part of that, as you can see kind of down in the bottom right-hand corner here, we have the files that are being shared. Now, as associated with AirDrop, you can also transfer an entire folder. You don't just have to do individual files. So as you can see here, item type, whether or not it's a JPEG, we have folders here, we've got videos. So keep that in mind. It doesn't just have to be a picture. Somebody can go ahead and say, hey, here's a whole folder, and completely transfer that over. So cups, mentioned that earlier. So cups is for print information on Mac, and a couple places, to kind of dig into. Private var spool cups. We'll give you some information as far as local printers, but we also have, the access log that shows successful completions of print jobs. Now, something to be aware of, obviously, in most corporate environments, they have fancy printers that have their own logs that you can cross-reference against the endpoints, but there are ways of tracking it on Macs as well. Spotlight shortcuts, very quickly, this is kind of the macOS built-in search engine that allows people to launch applications, look up specific files and folders. If you are seeing things where you see a folder that has a no index, I would start thinking you definitely have an advanced user. So essentially, if somebody adds that to a folder, it's not going to be indexed by Spotlight. And there's two types of people in the world, those who hit the command space bar to start opening stuff and those that don't. I use it all the time, so my Spotlight shortcuts list, plist, is quite long. And here you can see where I might have typed AUT, and then Automator popped up, and sure enough, that was the display name, and then I can see where it launched from. So we will have that as an artifact for you. So once again, explaining how somebody opened a file can help show that they knew what they were doing as part of your investigation. Tracking iCloud usage, and I know we're starting to run out of time here. I'm gonna kind of run through a lot of this, but feel free, please reach out. Happy to talk more at length about a lot of this. But macOS heavily recommends the use of iCloud Drive, which can sync your desktop and your documents folders to iCloud. And iCloud, is controlled. We have the Apple ID with both an email and a numeric identifier on that. So iCloud Drive heavily uses symbolic links for storage so that when you're copying things, there's not duplicates everywhere. Essentially, when you click one, it's actually opening somewhere else. But iCloud has several directories that's going to have a lot of the configuration data that you're going to want to look through in the library and application support directory structures here. And here you can see at the bottom the cloud docs, the protected cloud storage, and iCloud. Here you can see under the application support, iCloud, and then accounts name, we have the file names store, which has the master value of the numerical ID and the primary email for their iCloud, which is going to be great. So once again, if potentially you're in law enforcement and you need to start sending search warrants off to Apple, you'll have some very good information that you can put a part of that as far as here's their numerical ID for their iCloud account along with their primary email. We also have things like the client DB, which will have the local files synced from iCloud on that device. And we have the server DB, which has the sync capable devices on this device, which we're going to talk about here in a little bit as well. And we are actually working on building out some specific artifacts for this, so you can just kind of look in and see very quickly what they have in their iCloud within Axiom. As you can see here, when we're looking at what's going on inside this database, we can see the client items, and we're going to see things like the quarantine information. We're going to see the file names of this, whether it be the folders or the actual files that are associated with that, what's being shared via iCloud Drive. So just be aware of that. Looking through these databases, a lot of really good information here. And then we have the documents, which is the library mobile docs. This is going to be the storage of the location for inside of iCloud. And you're going to be able to see, here's a symbolic link of the documents folder within that. But you're going to be able to dig through and see everything that they're syncing inside of iCloud so you get a better understanding of what's being accessed. We also have application usage. So installed apps on their Mac and what's being installed. So you can actually look at the install history plist. This gives you that information so you know everything that they've downloaded from the App Store and updated on their Mac. We can also see things, whether it be the info plist for those app files, but apps installed directly not on the App Store will have only that info.plist, which you can then dig into to learn more about that specific artifact. I always like to exclude the com.apple, which is the reverse domain of the different applications. You can do that inside the advanced filtering in Axiom so that you're only going to see the third-party apps versus seeing all of the native Apple apps as well. A little bit more on the application usage. So we can actually track the network usage of applications as well. So here on the right-hand side, you can see we're looking at Safari here, and we can see things like the first used, the last connected, and most importantly, the Wi-Fi bytes sent and received. So if maybe they're using an application that you find a little suspect, or you're kind of curious about, and they're saying they never use it, and you look inside the application usage piece and you see that there is a lot of data being transferred here, that might give you a little bit more ammunition to start questioning them a little bit harder. You're also going to see down there, you see mobile bytes sent and received. That's going to be for iOS devices that you have a full file system level image. You can see both their LTE data as well as if they're connected to Wi-Fi for that. So just be aware of that as well. And then Safari data. So we have a lot of artifacts around Safari. And something I always like to tell people is if you're looking at their Safari history and you're not seeing a lot of information, that might be a clue in and of itself that something's kind of awry and that they're trying to hide their tracks here. So looking at some of the Safari preferences, the defaults for Safari, homepage, apple.com, default search engines, Google, history kept for 1 year, downloads folders are going to downloads, keep downloads for 1 day, and then the auto open for safe files is yes. So this is going to be kind of the standard default of what you're going to see inside of Safari. Now, where can you see some of their Safari preferences? Well, look in the com.apple.safari plist and you'll be able to see some of those preferences on how they have Safari set up. If the default values are set, some of those keys aren't going to be present. So you'll know, like, hey, if I don't see that value, it probably means that they haven't changed from the default for Safari. Here you can see we've got a lot of data that's being changed. The search provider being DuckDuckGo. You can see here we have this set for manual remove of items, so it changes the time for that. You can see always prompt for download folder is true. So here that's what it's going to look like. So ask for each download, and then auto open safe downloads. Well, I have that false in the plist. So guess what? It's going to be unchecked here. So you can kind of see what it looks like if that plist has values changed, what it would look like inside the user's window. And then downloads. So the downloads plist inside the Safari folder will have the last 20 downloads or the last day of activity, depending on how they have that set up. But always remember, look at your where froms, look at your quarantine data, because there's going to be good data about what they've downloaded. Even if they've downloaded stuff in private browsing with Safari, guess what? That still gets captured inside the quarantine events database, so you'll be able to track it there. And then we do a great job carving a lot of Safari history. I like to mention this, especially in your iOS investigations. Your iOS cases, you're probably only getting about 30 days worth of parsable data for Safari, but we can still carve the database and get a lot more hits out of it. So keep that in mind. If you are only able to get a logical extraction of iOS device, which is running APFS, you're probably only get 30 days of Safari history. If you get that full file system level image, you'll be able to carve that data out and you should get a lot more hits from that. Also, we have a couple of artifacts for Safari iCloud devices and iCloud tabs. Now, why is this important? Well, if you do a search warrant and you only come back with maybe a computer or maybe you only have their phone and you process inside of Axiom, you're going to have the Safari iCloud devices. And here we see 2. And when we're looking at that, you get the unique device identifier along with the device name. So now you know potentially another data source that you need to go find. Now, what's really great about this, though, is potentially, let's say your suspect has 2 iPhones. One is where they do all their illegal activity, and the other is where they talk to their family and everything is above board, but they use the same iCloud account on both of those. Well, you can see what they are doing inside of Safari on their other device with the iCloud open tabs. So if they have their open tabs open on their device where they're doing a lot of their criminal activity, guess what? You'll still be able to see it because it's all saved inside the Cloud Tabs database that we are parsing. So you'll have that device name, the dates, and the URL for when they visited that site and what's still open on those additional devices there. Snapshots. So if you have Time Machine running, you're going to have snapshots being created automatically, roughly a new snapshot approximately every hour. And you're going to have this snapshots automatically being created if there's any sort of software updates, just because Apple wants to make sure that your data is protected. If you are looking inside of the bash history and you see things in here like tmutil snapshot or listing the snapshots, once again, they're going to be able to manually create snapshots as well and list those. But snapshots will be deleted automatically, starting with the oldest as the machine is running out of drive space. This is what it looks like when the end user needs to use snapshots to kind of restore. Snapshots is definitely something we'll be looking into, along with more time machine backup functionality for processing inside of Axiom. But definitely let us know if you're seeing a lot of snapshots that you would like to be able to see support for. We definitely want to build the tool for our customers. And Apple now has their own, but you're going to have to definitely think about that. And one thing that's great about this is it's all trackable. It's stored, all their travel docs, all of their receipts, all of that's going to be saved inside their wallet, so you can look through that information. I put this in there as well because it's actually stored in a JSON. And why I put that in there is because you're going to see things like header fields and secondary fields and back fields. Apple essentially lets developers put whatever they want in those information fields. So you're going to see all sorts of different data in there when you are looking through this information. So definitely keep that in mind as well. People always ask, what can I do as far as keeping up with Mac? I highly recommend having testing devices so that you can test older hardware with newer software and, vice versa, the newer software on new devices on old. Having the Apple Developer Program is very helpful. It's $100 a year. You have access to all the latest builds, and you also have access to the Apple developer community for forums and asking questions and getting feedback on stuff. We have a macOS forensics examinations course, the X350, that's coming out soon. So definitely take a look, or excuse me, it is already out. Definitely check that out as our 4-day class. It's fantastic here at Magnet. And then some additional resources. Obviously, I love the Mac Tracker iOS app. You can punch in any type of model ID, and it will tell you everything you need to know about that specific Mac, including the what OS it was shipped with and what's the latest iOS or Mac OS it can run. So a really good resource. Sarah Edwards, she's fantastic. A lot of great research. We have Yogesh, Alexis. Like I said, the Apple developer website. Forensic Wiki is great, and then I put Mac Rumors on there because sometimes they actually talk about things such as the new volumes and things like that with Catalina. They were actually some of the first people to start talking about that. So definitely keep that in mind as well for the additional resources piece. We are right at time. Thank you all so much. Make sure you can email me or feel free if you've asked a question in the webinar. I'll be getting a report of that, and I'll definitely be reaching out to everyone. But thank you all for joining us today, and have a great day.